And there's a moment in every meeting room, every lecture hall, every boardroom in the world where somebody presses a single button, the lights adjust, the screen drops, the camera comes on, and the whole room changes. Nobody thinks twice about it. That's the whole point. That's invisibility. That's the work of people who spent their entire careers building something specifically designed to disappear. And to understand how we got there, you have to go back to a time when none of that existed, when the control system was a relay, when a programming language was binary, when you told the projector to turn on with the same command you used to press play on a tape deck. This is a state of control, and this is part one. The story of control in AV doesn't start with a whiteboard full of specs. It starts, like a lot of good stories, with someone who couldn't get a job. That includes George Feldstein, the founder of Crestron. To tell that story, we have George's son, Crestron CEO Dan Feldstein.
So Crestron was founded in 1972 by my father, George Feldstein. He had recently been laid off from his job as a chief engineer and was looking for something to do. Decided, and this is in his own words, that he was unemployable. So felt the only answer was really to go it alone and start his own business. He really didn't have any grand idea. He didn't have big capital backing. So armed with only a old drafting table and a set of Craftsman tools, he put out an ad in the phone book for engineer for hire. And while he was waiting for calls on that, he started going around to local businesses and seeing if they had any industrial equipment that needed repairing or enhancement. So that kind of kept him going at the beginning. Slowly, he started to get some design work to engineer products for other people. And shortly after that, he added some basic manufacturing capability so he could offer full design and build capability. So in the beginning, he was only making things for other people. He was taking their ideas and bringing them to life. One of the things that he did was a product that was designed to control slide projectors, lights, drapes, other items, basically through relay control. And it was a fairly simple concept of just buttons on the front, relays on the back. You could program what they did primarily through dip switches. And now here you are, now you have a control system. And unfortunately, the company he made it for went out of business. So he found out who they were selling it to and tried to keep selling it to those people after slapping a Crestron name on the product. This now became the first product that was sold under the Crestron name. And he continued doing that for a while. Learned about the industry more, put ads in magazines, started going to trade shows like the NAVA show, which was sort of a predecessor before Infocom. And from there, it was sort of history, as he would say. Now we were embedded within the AV industry, and we were off and running.
For me personally, I started out, after graduating as an electrical engineering major and looking for a job in the early 90s. And I was very fortunate to interview with George Feldstein himself and answering an ad in a newspaper. And believe it or not, and really didn't know what I was getting myself into, but I'm so glad that I got myself into it. It was, as many people say, they happened upon this industry by accident, and that's really what happened for me. Starting my career at Crestron, doing programming, but it really wasn't the type of programming that you would have expected or have learned. And what was nice about it is that you got to see the results of it pretty quickly. You got to see when you did something happened. And that was, I think, what was probably what really lured me in, because you were able to create results and you were able to see people's reaction to them. Fast forward, I turned into one of the first independent programming companies, and really a lot of the story can be told after that as far as the changes in the industry and so forth, but really look to be able to do programming on a more personalized level. And I know that you probably had a similar take on it, is trying to understand people's needs and provide really a customized solution. Whereas at Crestron, the objective was to sell equipment and to get systems in place. And there was such a small number of people who knew how to program them, but quite honestly, the equipment didn't do anything without programming. And
well, again, I am the poster child of purely by accident. But always wound up, when I looked back and I kind of had to do a perspective of my career, and I started remembering some things that, like, I didn't intend to get into programming at all. But I remember being 7, 8 years old with an Atari 800 with my friends and programming blackjack games in BASIC, but there was no memory. So we would spend all night writing this game in BASIC, and then when you were done, you turned it off and it went away. So, I mean, talk about, being in the moment. And that was actually my start when I really think about it. I just didn't know it at the time. I remember being at a conference, a meet and greet for a distributor, and met people who would be key in my life for the rest of my career. One became my future business partner. The other one got me my start, a fellow by the name of Adam Stone, who started a little company called D-Tools. So we started out as custom AV guys, and our pride and joy, I still have it, he sent it to me, was we started with a brochure, a glossy brochure that we were so proud of, that started with Imagine. And then we went into telling the whole story. And so we were integrators for several years. And that is all of a sudden when Planet Crestron came in. And I don't know if people, I think I've told this story to you before. I told it a couple of times, is that I didn't intend to be the programmer. I was the salesperson. And I sold my first large system in 1991. And it was big for the time. And I had a programmer, somebody who was going to do the Crestron system. Lo and behold, he has a family tragedy. He's gone. And we're a small company. There's only 3 of us. And I called the client. I tried to explain to him. He says, I really appreciate your story and I sympathize, but you signed a contract. You have a deadline. This needs to be done. And I locked myself in my office for 3 weeks and taught myself how to program in the original DOS tools with Crestron. And the rest is history. But at that point, we were integrators for all times. Started with Crestron. Famously got kicked out of my first training class by Fred Bargetzi, who from day one until forever on, completely denied it, but I kept the receipts on it. And we did that and learned a lot. And at that point, Adam was heading off to D-Tools, and I was looking for something different. I was actually in the middle of thinking about a move to the East Coast. And as I was calling friends to kind of bid my goodbye, I got approached by a company who said, hey, we're doing this new thing. We're taking kind of the commercial model of specification, but we're going to put it into residential and into estate systems. And I went, that sounds fun. So he said, and so, we've got interior design, we've got lighting design, we've got electronic systems, which you're part of, but we really think this programming thing could happen. And so on the other coast at about the same time as you, where you were building your the original capes, Crestron authorized independent programmers. I still remember it. We were doing our West Coast version of it, just with some other services. And so we had parallel tracks kind of once we hit that third party side, which was, we're part agnostic, we're brand agnostic. We just want to work with anybody who'll work with us to deliver the results. And we did. We built, along with you, some of the first third party programming firms in the nation, I guess in the world, really.
Peter Knapp from Extron wasn't just one of the first programmers, he was one of the first architects of programming systems. And it all started with bigger TVs.
So I guess the biggest influence to it was more and more things being shown on larger screen TVs. The idea that people were no longer having to use terminals to a larger computer. And now they had PCs or personal computers that they could have an image on. And if they wanted to share that image with someone else, in the past, you had to have a slide created for it and then take that slide image and bring that slide image with you to a meeting and put it into a Kodak slide projector. Now, you can take your PC and connect it to a large display, like a 24-inch CRT large display, and share it with a group of people. And then people say, well, I can get, instead of a 24, we can get a 48-inch large display. And then someone said, well, the same thing that's in that display is a projector. Let's put it on a projected image. And so now that we've got things that are further away from people's fingertips, there needed to be a way to reach out to do that rather than, hey, you go over there and turn on this. You go over here and turn on that. It was tell the control system or tell an object. I press a button, a physical button on a panel, and it fires off a couple of relays. Or it tells a 232 port or an RS-422 port, because a lot of these devices came from studio recording and other types of things. You told the device, hey, on 422, play. The first thing on a Sony projector to tell a Sony projector to turn on was actually the play command from a Sony U-matic record deck. So the same command you use for play on the record deck turned the Sony projector on. And guess which one turned it off? Stop.
From the first independent programmers in the world to the beginnings of automation. Before our friend George Tucker worked for Crestron, he was introduced to automation in the Hamptons.
The idea that mechanical objects or mechanical gears could change how your environment was operating. So whether that was HVAC or the lighting or the way that floors moved. Growing up in the Hamptons with very, very rich folk, not the nouveau riche that you know now, but back then you could find some of these things like automated dumbwaiters. You press a button, it goes to the floor selected. Those kind of things fascinated me.
Now you had a need. Rooms were getting bigger. Devices were multiplying. And someone, somewhere, had to figure out how to make them all work together. The question was, what does that even look like? What's the language?
Most of the people in the AV industry were really more technicians. They were installers. So he didn't want to go down the route of a traditional programming language because he felt that wasn't who this industry was, certainly not at the time. So by working with combinational logic, that kind of fit the experience that a lot of the people in the industry already had. So that was really the beginning. So I remember a lot of time spent with him after he would get home from work, sitting there with a CN rack, trying to create programs, trying to make it do things, and really finding where it worked, where it didn't work, things like that. Now we have large QE departments and internal and external beta programs. But back then it was basically the two of us sitting there with the latest firmware release, trying to see if this thing worked.
Mike Leitensdorfer started programming before either of us, way back in 1989.
1989, I got hired on with a company called Communitronics. They were an AV integrator back then, very diverse in their company structure. We had a large service department servicing 3/4 inch, 1/2 inch tape decks. We had a recording studio where we made commercials for corporations back in the day. We were also doing large tape sales for audio recordings, cassette tapes for churches. So the business was multifaceted. We had our own wood shop, our own metal shop. So back in the day, we were hanging CRT-based projectors, mainly Barco, and we would make our own Barco mounts, ceiling mounts that were much easier to hang the projectors. So my father-in-law would, at the time was my boss, but now he's my father-in-law. He would come up with some fantastic designs, and the metal shop guys really did a great job. Equipment racks weren't even that good back then, so we would make our own equipment racks. out of particle board wood and customize them to the customer's needs. About a year into that, the chief engineer at the time moved on, left a big void in the company. Looking back, foolish young me said, "Yeah, I'll do it." And the rest has progressed since there. So I got kind of dropped into into the fire and had to learn programming in the fire pretty rapidly.
Programming started on paper for a lot of us. The way you actually programmed the system is you drew it out logically and then you translated it into the computer. And I can't imagine doing that now, but it was a great way to learn, and it was a great way to teach people, is actually drawing out the logic that you were going to use to actually input into your program and to make things work. Making changes on paper was a lot harder than it is on the computer, but it really was the starting point for all of this.
Yeah, and those developed into, what was interesting, and we kind of go back to the beginning of the story when, it was the big two at that point, right? You had Crestron and AMX. Crestron was, again, simple. The logic was in the name. The original workshop software was, although it was in DOS, was very visual for its time. You had an input, you had an output. And, going back with, we were talking about kind of the garage door opener and Mr. Feldstein. And there was the first iteration of control, which was true binary, right? Because it was relays. It was on, it was off. There was only two. There was no middle, right? But when we went to other devices, you had states. But more importantly than states, you had environmental conditions. And that's when we started seeing logic come into play. Because, although binary was great as a starting point for yes, no, it really was a result as opposed to the starting point. And this goes back to all the precursor programming languages before, which were the basic operators that we still call them the basic operators, or, if, and, when, then, else, not, right? Those are kind of the, we have the 10 commandments of logic, right? And that was exactly what you were talking about, which we needed to plot that out in the decision tree before the code could, because we had to be super efficient with it. I always told the story was that, the first processors that we put in, they had little chips that I used to keep a little vial of the chips, because when you loaded your program, it had to stay non-volatile, because the minute that you burned it to the EEPROM, you had only so many shots to do it. So the concept of save as and load and reload and reload and reload, you were literally sitting there going, I got 8 shots left on this thing before I have to crack it open, pop the chip back in, swap it around, and pray that it comes back up. If you ever ask an old programmer, you ask them about the EEPROM chips, I can guarantee everybody had a little vial of those suckers around and the puller. So you had that one side with Crestron, which was taking the logic-oriented, the flowchart, the visual side. And then AMX came from a different approach, where it was a command line interface. It's like you open up any CLI, that's what you had, and you'd save it. And that's when they started introducing things like libraries and include files and drivers. And they both achieved the same result. They just had different teams who had different objectives, what they felt was going to be the best tools possible. And that was kind of the beauty. And it was the iron sharpens iron analogy at the time, because they both thought they had the superior idea and they kept pushing each other. The hardest part, though, was I felt like I was sitting there kind of going, yay, 2 Christmases, mom and dad are fighting, because you had to straddle both sides, right? And you literally had to retrain your brain from one to go to the other, and you'd find your way. Now, again, it's still the same projector. It's still the same VGA switcher. All of these things, you just had different tools that you had to be flexible enough to be able to accommodate it. And that's the interesting part. And this is what I like about, our interviews, is because they were both in different camps at that time. And again, we obviously have the history of Crestron, but there was a deep history at AMX, and we had very strong ties to them. I spent many nights with, the brain trust of AMX with, Scott Miller, who, was an absolute madman, but brilliant. Mike Olinger, Kat Fowler, now, in PR with Catalyst. But they all took that approach. And I always viewed it as it was the Beatles against the Rolling Stones. It really was like the Beatles were. There was intricacy, there was thought, there was nuance. They were right. That was kind of the Crestron camp, right? It was there. It was elegant. It was restrained. And AMX at times was just flat out rock and roll, four on the floor, and away you go. But that was the beauty, because they all still were taking that path and just steamrolling everything along the way, because it hadn't been done before. And we talk about the heads of the companies, but they all had great engineering engineers behind them. Crestron was sitting on one side, and you had Randy on the sales side, but you had Fred Bargetzi. Fred Bargetzi absolutely drove so much technology during that period of time. And then on the other side, you had AMX. You had Mark Luno, who we used to call the madman of code, who was pure rock and roll mad scientist. Rob Ward, who's now 20 years at Microsoft now. Both of them, patent after patent after patent after patent, coming through. And the support, and it even came down to the support teams. We used to have the regional teams. AMX West and Crestron West were the people who were my go-to people. They had engineers that were sitting there who, again, because it was all new for all of us, we all just were figuring out how to row in the same direction. You were on the other side. So you had a completely different regional team for both that you were dealing with. But they all still worked together. And that was the beauty. And that's what I also did notice as well, is that even regionally, we saw things that would develop, like things would happen on the West Coast that we would start pushing that, we'd see different from on the East Coast, or, from the center of the country in Texas. We had the metropolitan areas, which were different than kind of some of the more suburban areas. But everybody was still kind of pushing. Let's not even talk international. That was a whole new ball of wax at that point. Because then you had not only different standards, but different standards.
Once you had a control system, it was just a box. And in theory, it could do just about anything, but you needed to program it in order to make it work. And in the late 1980s, that meant you needed people that were specialists in a very particular skill, a programmer.
Binary?
Who wants to learn binary?
That's like somebody who looks at us and goes, but it's just ... right? Whenever you're on a project. Oh, it's just binary. Yeah, no. Binary is part of it. But really, and I think, you nailed it earlier when we were talking, what we're talking about is logic. And logic had its evolution into the control system world. Started out as binary, and we talked about relays, right? On, off, 2 states. There was no in between. That worked great when there were simple machines, let's call it. Again, because the light is on or off. Well, the dimmer changed the lighting industry. Same thing happened in the programming community. When we went away from a dual state, one or the other, we had to grow and adapt for everything in between. And that's when control system programming learned and got its origin of learning how to live in the gray.
Imagine variables. That's where binary all of a sudden breaks. Variable can be a lot of things. and it's not just one or the other. So that really was where we graduated, and how what we did became a lot more advanced, a lot more mainstream, and a lot more powerful. The use of variables and the ability to make things happen and create even more magic than what we were doing previously. As we said in the beginning, pressing a button and seeing something happen, that was where we started and what people were amazed by. But over time, we raised the bar and we had to do a lot more.
Programming some of these were as simple as taking a front panel button control on a controller. One of the first ones I worked on was York Controls ProLine series. The front of that ProLine series device had a bank of 8 buttons on the front of it. You put it into program mode, and bit by bit, you program the message you were sending by turning on the bits to indicate what character that represented in an RS-232 or 422 string. You got really good at converting binary to ASCII. For instance, there's a very familiar projector back in the late 80s, early 90s called Electrohome. And Electrohome had an incredible protocol that could do any sorts of things. But the problem was that was a 64-bit pattern in most of these things. And yes, I don't know why these things stick in my brain. But it was a bit pattern that you had to then encode into words that sometimes didn't really mean anything to you as the programmer, but you knew that bits 32 to 40 represented the brightness. Bits something to something would represent this. And so you understood how to program that based upon the levels you're trying to set on the device, or the objects you were trying to set on the device.
Each piece of equipment has its own personality, regardless of what the manufacturer's manual tells you. There's things in the manual and the marketing that don't tell you. What's your turn-on time of a CRT projector, and how long can it be before that CRT projector can accept a secondary command? Things like that. Stuff you'll find out that manufacturers don't even know that they've not fully tested. What I found was every third character wouldn't switch inputs. I did some digging and found out that the manufacturer's card would accept lowercase, lowercase, uppercase, lowercase, lowercase, uppercase was the only way it would accept its commands. So I would send a lowercase a for the first switch, a lowercase b for the second switch, and an uppercase c for the third switch. And then that same repeated pattern. We then contacted the manufacturer and said, that's not how it works. I said, yes, it does. And they had to test it, and they said, yes, that's how it works. Because they had never actually done it.
Here's the part where it gets interesting, and this is the source of many sleepless nights for many OG programmers. It would drive any programmer mad. Every device in the room had a control port. Sony had one. Barco had one. The switcher had one. The projector had one. And pretty much none of them spoke the same language.
232 and 422. 422 borrowed from the studio control devices. Actually, both of those things had a very robust two-way communication for most devices. You send it a string, it sends you a response. Sometimes the responses were something just as simple as a single hex character representing an ACK or an acknowledgement. Or it could be something maybe text-based. You see the word come back that says, okay. And you're like, okay, what? Okay, you got the message. Okay, you did what I asked you to do in the message, but what did you really do? So in a lot of cases, you had to, once you sent a command and you got the okay back, you then had to send another message, a query, what are you doing? And then you get some sort of response back from that telling you what I did, how I made that happen. One of the things that I likened it to was the universal translator on Star Trek. Universal translator, take any input, go to any output, and do anything you wanted to it. But it all depended upon knowing what you needed to do.
For me, when I went to trade school, learning about MIDI was the huge opening that MIDI controlled for many years was considered the control system ideal, because you could do so many things on so many levels. Like MIDI has that 0 to 127. It has system commands, sysx commands that were unique to each device that you could implement. using a sequencer and then modifying those things to say control robots or to control appliances or to control your home lighting and HVAC was a pretty interesting leap forward. It didn't become the standard, but it really was a model, at least in my head, for understanding how you encapsulate all that and you control them discreetly.
All of that programming, the bit flipping, the ASCII strings, the hoping the projector was listening, it was building towards something, a way to actually show the person in the room what the system was doing, which meant somebody had to invent the interface. The first ones, well, they were incandescent light bulbs on a panel.
My story isn't necessarily light bulbs. I would have been happy with light bulbs. So, as we've said, I the bulk of my career, especially the early part of my career, was in residential estate control. And the one thing about estate control in the 90s, and different cities, of course, cut to Las Vegas, Nevada. I have a client, a great client, pushing the envelope on things, and everything was kind of answered with, why not? There was this very few times, I always laugh when people always say to me, it's like, cost is no object until I tell them how much it costs. Very few times in my career have they just not blinked and said, did I stutter? So, and it's happened. Rare, but it has happened, and this is one of those stories. So, have a large place, already doing crazy stuff, working just on pushing the boundaries of this. And request comes up. Client has, I'm going to call it the grotto, because that's really what it was. I mean, it's like, if you ever heard the stories of, the Hef's place, and this place was close to a full-fledged water park in the desert, obviously. And the question comes up, well, it'd be nice to be able to turn this thing on and off. And we kind of look at each other and we go, yeah, we can do that. Before we knew how we were going to do that. But that's how many of these stories started. And this goes back into the touch point, because it's 115 degrees outside. Nobody was going to go outside and turn things on and off and burn their feet. Like there was a reason. There was a method to the madness when the request was made. And I'm like, that actually makes a lot of sense to me. And I was like, okay, let's figure this out. And again, the problem that you have is that you don't, again, in a binary world, it was like, okay, well, maybe you turn a pump on it. This was so beyond that. It already had its own controller sitting in the background that, again, this was a production that was going on in there. So it's like, okay, what are we going to do? Well, let's find a company who maybe can do something like this. We find a company who can handle kind of the water side of things. And they're like, oh, yeah, no problem. We can do it. And we went, well, there's one catch. We need to control it from a touch panel. Change states, flow, trickle stream, rushing. Yeah, we don't do that. No, we've got to find a way to do that. Yeah, we haven't come up with that. It was like a company at a time. And I went, okay, let's figure it out. And I guess after a while, people were like, okay, yeah, well, let's figure it out. Because we had to convince them that, like, look, there's going to be a need for this. And this goes back to the detective work. And so I talked in another segment. We basically had to convince them to tell us how their system worked and give us absolutely the baseline of how this stuff worked. And we went, okay, we need to pretend to be one of your controllers. They're like, yeah, no, we don't do that. That's everything we do. Yeah. Sure enough, and it was one of the first NDAs that we had ever signed at that point. And we had to create an RS-485 driver to be able to have our system communicate at the level with the timing and you name it, and the callback and the return. And again, if you ever want to if you want a cure for insomnia, type history of RS-485 in your Googles and be glad you don't have to deal with it. And we did, and we threw our time at it, to the point that after we were done, literally the manufacturer was like, yeah, people would call and ask about things. They're like, yeah. And they gave us they had our direct line. We were, in the early days of the web pages, like we were listed as like, just call them. But, necessity drives those things. And this is, once the touch panels became more prevalent, this is when the acceleration happened. Because you had the sales side going, imagine, and the engineering side going, don't you say that. The same thing happened in boardrooms. It was no difference. I mean, everybody has an executive boardroom horror story if they've ever done corporate work. Everybody has one where you get the craziest requests and they go, oh yeah, we can do it. And then everybody else is sitting there going, I don't know how we're going to do this, but let's figure it out.
In some of the early systems, a lot of times all you did was you turned a light on maybe a button panel, or you turned a separate light on a separate dashboard that had this light turned on when you had a projector on. This light turned on when the video player was in play mode. And and as I refer to them as lights, they truly were lights, incandescent bulbs on a panel in a lot of cases. Manufacturers like York Controls, AMX, Crestron came out with these really cool touch panels. And they were all sorts of different manners. Some of them were LCD based, some of them were electroluminescent type panels. And you basically were creating a graphical interface. And very varied forms of it. Some cases you were editing directly on the panel, creating buttons by selecting, okay, I want a button that's this size. Well, you get 3 sizes, small, medium, large. You can then place that button in any one of 16 spaces on the touch panel. And you can put some text in it, usually anywhere from 4 to 8 characters of text in that button. And the button can give you 2 states. The button's on, the button's off. Early 90s, 2 of those manufacturers, York Controls and AMX, merged. Peter York, who was the founder of York Controls, had a really interesting device. He was trying to create a touch panel for, as he put it, low vision people. And I'm like, okay, a touch panel for low vision people. He says, yeah. On the back of this touch panel, there were a bunch of different solenoids. So as you touch different areas on the touch panel, you could feel, did I touch where the button was, or did I touch somewhere else? And so you could actually have the feeling of the texture of the buttons. Did I press in the right place? And so he added touch sensitive feedback back to the touch panel. It was a great idea. It never really took off because of the whole concept of you're continuously tapping the back of a glass screen. And there's motion, there's movement, and that sort of things. And so that never really took off from there.
Through all of this, the commercial AV control world had a remarkable characteristic. For most of its history, it was essentially run by 2 companies, AMX and Crestron. And oddly enough, for a long time, they got along.
Ish.
I don't remember that part, honestly.
I don't ever. I'm not saying nothing about that one though.
I wish that I had a camera at this one moment that I can remember in my mind that we're at an Infocom party and Randy Klein and Scott Miller were talking to each other, and I almost thought like the world was going to explode.
AMX and Crestron kind of were the 2 similar things. One was programmed in one manner, one was programmed in another manner. One was a state machine program system using logic-based gates. The other one was a text-based program system using a specific API to communicate with it. Both of those systems had their followings. Both were very good. Both were very nice in how they operated. Different manufacturers started to get into what other manufacturers did. When both AMX and Crestron were only doing control systems, everybody got along with AMX and Crestron. In fact, the funny thing was, during that time period, I still had contacts when I was working at AMX. I still had contacts at Crestron. Crestron had contacts at AMX. And we were frequently talking to each other about different things. Normally not about our own business and how our own devices work, but hey, how did you work with XYZ's company thing that did this? But as the control manufacturers got into developing, marketing, selling switchers, that was the first thing. That's where the division started to happen. And then as these control manufacturers started to get into other things, media players, audio systems, there was an interoperability between Extron and AMX, where AMX and Extron were able to communicate between Global Viewer Enterprise and the AMX controllers.
Prior to the internet, we were dealing specifically with RS-232 standards, 422 standards, RS-485 bus standards. All these different protocols, hexadecimal. We had to do hex signal. We had to do binary signal. We had to do ASCII signals. IR, stripping IR, making a serial command out of an IR carrier. Just numerous amounts of different things that had to be done to get all of these dissimilar components working together as a single uniform system.
That started in 98 with the CNMSX Pro, which is also when we introduced the first Ethernet port on a control system. And that really was revolutionary at that time. People were just starting to get onto the internet, starting to go to websites. And a lot of people are like, well, why'd you put that on there? And to be honest, we didn't 100% know either. We had some thoughts. It certainly made program and firmware downloads much, much faster. But other than that, we didn't fully know where we were going to go with this. We just knew this is the path forward and this is what we need to do with this.
Crestron ships the CNMSX Pro. It was something nobody asked for.
Who expected an Ethernet port on a control processor when we were just not even understanding what a network was at the time? And this was innovative, but I believe that they didn't even know what this was going to turn into. So the Ethernet port, the port on a processor that changed everything, and it opened the door to remote management and managed services into a world where your control system could talk to any system anywhere. And this gave you that flexibility to do things that weren't able to be done before. It opened the door to a market that went from 2 dormant players to a full ecosystem, to a debate that's still going on today about simplicity, complexity, and whether we ever really solved the problem we set out to solve. And to the people, the programmers, the ones who turned those empty boxes into something, the ones whose best work you've never thought about because it just worked. That's part 2 of A State of Control next time.
The network for the AV industry.
What are you listening to?
This
is AV.
This
is AVNation.
This is AVNation.
Hey listeners, it's your AV sneakerhead, Jennifer Weaver. Listen to AV Career Masterminds, where I chat all things job-related in the audio-visual industry. You can find AV Career Masterminds where you subscribe to podcasts.